Hi, this is SM and welcome to my channel Concept of Mechanical Engineering. Here we are studying thermodynamics. In thermodynamics, we have completed the first chapter, which is Basics of Thermodynamics. Today we are going to do the numerical based on the basics of thermodynamics. In previous class we have seen the method of temperature measurement which is used before 1954 and the method of temperature measurement which is used after 1954, which is the current method. So here we are going to do the numericals, and these numericals are mainly based on temperature scales. The first one is in a new temperature scale, that is P scale, the boiling point of water is 100 degree P and freezing point is 300 P. Find out the reading corresponding to 0 degree P on centigrade scale. So here we are going to construct a new scale in which the boiling point is 100 P degree and freezing point is 300 degree P. And we want to know the value corresponding to 0 P degree on centigrade scale. So in previous class we have seen that let's solve this one. We know that P equals to A plus BT, where P is any thermometric property. P is any thermometric property and A and B are constant. T is temperature. So we want a relation between this P scale and centigrade scale. So we will divide this in two parts. First we will see on centigrade scale and other one is P scale. So this is a P, this P is any thermometric property. We can write this relation, and T is temperature. If we want to really write this relation in P scale, we can write P dash equals to A plus BC, where P dash any thermometric property, A and B are constant, and C is temperature in centigrade scale. In P scale we can write P dash equals to M plus N P, where P any thermometric property, where P is any thermometric property, M and N are constants. Sorry, this P dash is any thermometric property, M and N are constants, and P is temperature. P is temperature in P scale. So don't confuse this P dash with P. P dash is the thermometric property and P is the temperature in P scale, and C is the temperature in C scale. As we have seen that P equals to A plus BT, P any thermometric property, A and B are constant, and T is temperature. So in centigrade scale we have denoted this temperature with C, and in P scale we have denoted this temperature as P. So for particular method and particular condition, that the thermometric property will be equal, so we can equate these two equations. So we will get A plus BC equals to M plus NP. A plus BC equals to M plus NC. After solving we will get BC equals to M minus A plus NP, and From there we can get m minus a by b plus n by b into p. This is the relation we have found out by equating the property of that thermometric property in P scale and in centigrade scale. So now in question what was given? It was given that a boiling point of water is 100 P in P scale and freezing point is 300 P in P scale. So for ice we know that C equals to, before solving that we can write that see here C, this m, a, b are constants and n and b are constants, so we can write this with these all constants with single constants, like C equals to x plus yp, because this m, n and b all are constants, so we can, in place of these constants we can put another constant, single constant, this is x, and in place of n by b we can put y. So this is the equation 1. So for ice we know that x plus yp for ice, that in temperature, that is in centigrade scale, the temperature, that is freezing point of ice is 0 degree centigrade, so in place of C we can write 0, this is x plus y, and in P scale in question it is given that the freezing point is 300 degree centigrade, sorry 300 degree P, so in P in place of P we can write 300. So this is equation 2. For steam, C is equal to x plus yp. We know that in centigrade scale, that is the boiling point is 100 degree centigrade. So this boiling point, in place of C we can write 100, in place of x, x, place of y, y, and in question it is given that the boiling point of water in P scale is 100, so we can write here 100. This is equation 2, sorry equation 3. So solving these 2 and 3 we will get the value of nx, x and y. So put the value of this x from here to here, we will get 100 equals to minus 300 y plus 100 y. So after putting this from here we will get x equals to minus 300 y. So we will put the value, we are putting this value from here to here, so we are getting this 100 equals to minus 200 y. From there we got the value of y as minus 1 by 2. If we put this value in this equation, we will get the value of x. So x equals to minus 300 into minus 1 by 2, so 150. The value of x is 150. So now C equals to x plus yp. So putting this value of x and y in this equation, we will get C equals to 150 plus y minus 1 by 2 into P, that is C equals to 150 minus P by 2. We got the relation between centigrade scale and P scale. Now according to the question, we require the value of, that is centigrade, we require the value. So this is the relation, C equals to 150 minus P by 2, and according to the question we want the value in centigrade scale according to 0P. So when P equals to 0, C equals to 150 minus 0 by 2 is equal to C equals to 150. So in question it was asked that find out the reading corresponding to 0 degree P on centigrade scale. So when it is showing that 0 degree P on P scale, then the value of water is 150 degree centigrade in centigrade scale. Now we can compare or we can equate our scale, that is P scale, which we have constructed in this question, with the scales we know that earlier, like F minus 32 by 180 equals to K minus 273 by 100 equals to C by 100 equals to 150 minus P by 2 by 100. We have also equated our scale with the well-known scale, temperature scales. Hence, the reading corresponding to 0 degree P on centigrade scale is 150 degree centigrade. Now let's see another question which was asked in GATE 1994 in 1 marks. The question is, the definition of 1 Kelvin as per the internationally accepted temperature scale is 1 by 100th the difference between normal boiling point and normal freezing point of water. These are options: 1 by 273.15 the normal freezing point of water, 100 times the difference between the triple point of water and the normal freezing point of water, 1 by 273.16 of the triple point of water. So we have earlier seen that the value corresponding to triple point of water is 273.16. So the answer is D, that is 1 by 273.16. That is, the definition of 1 Kelvin as per the internationally accepted temperature scale is 1 by 273.16 of the triple point of water.